Hello, hello, good evening, everyone. Am I audible?
Yes. Good evening.
So we will wait for 1 or 2 minutes. If the students will join, then we will start. And also, the video will be recorded and it will be uploaded on YouTube, and the link will be posted in the NPTEL portal. So if anyone missed the lecture or if anyone starts from the middle, can see on the NPTEL, can see on the YouTube. The link will be uploaded on NPTEL portal. So welcome to the week 3 of this Principles of Signal and System tutorial session. I'm Abhishek Thakur, Prime Minister Research Fellow at IIT Hyderabad. So in last lecture we have solved various problems based on the week 2 lectures. This time also we'll solve a number of examples which will be
Four is going on. The big
yeah yeah
one line is 22nd. There is a phase after actually tutorials. For some reason, maybe they start of tutorials. So
yeah yeah
if you can jump in, really you know not the same problem, same model. Actually, I understand the original idea of tutorials is to help solve the coming assignment, right?
yes yes
It's deadline. So, for example, you are covering week 3. Week 3 deadline is over. No, you are ready week
yeah.
4.
Oh, I actually like this started little late, so I did not had this.
Okay.
Okay, so from the next week I will see
Yes,
what is
yes,
covered in
yeah,
the
that,
week 4. I can escape
yes,
and we
yes,
can solve problem based on week 5.
yes.
Yeah, so thank you for figuring it out. So okay, so we'll see most of the question based on the impulse response and the step response. Um, but before that, we will see some of the concept which we have discussed in the last week. Anyway, like these lectures will be useful for gate perspective. So even like assignment, you can easily solve through the whatever lectures is given on the NPTEL portal. All the questions are assignment questions are based on that lecture. So for gate perspective, this lectures will be tutorial session will be also useful. So in last lecture we have seen that some shortcut of convolution of two rectangular pulses with equal width and also unequal width. So here you can see like whenever two rectangular pulses are given, so we have to just keep these thing in the mind that whatever is written in the notes point, like whenever the two rectangular pulses, like the convolution we have to find of two rectangular pulses of equal or unequal width, either it will result in trapezoidal or in triangular pulse. It is it will result in trapezoidal means trapezium shape only when it is unequal width. When both the rectangular pulses have equal width, then it will result in triangular pulse. So the width of the output is equal to the sum of the width of the individual rectangular pulse. So like let's suppose in this example, it is from minus t to t, so the width is here 2t. Here also width is 2t. So the output width will be the sum of the input, sum of the width of the input signals. So 2t plus 2t, so output width will be 4t. And the width of rising arm as well as the width of falling arm of a trapezoidal signal are equal to the width of the smaller width pulse. Like let's suppose in the next example here you can see that the input width of pulse 1 is 21 T1 and input width of the pulse 2 is T2. So now this signal will be trapezoidal because both the rectangular pulse don't have same width. But what will be the rising and falling arm duration? That will be the duration of the pulse which is having like lesser duration. So that is W1, that is equal to T1. So it will increase up to T1, and it will also decrease up to T1 duration, and the remaining duration it will be flat. Okay, and remaining duration, how much it will be? Total duration output width will be T1 plus T2, because it will be sum of both the pulse, and it will increase up to T1, and it will decrease also up to T1. So the flat area will be T1 plus T2 minus 2T1. So that will be equal to T2 minus T1. So here you can see uh, this is T2 and this is T1. So this width is T2 minus T1. And also, what will be the slope? We have also discussed about the slope. The slope of rising arm is equal to the product of the individual amplitude of the rectangular pulse being convolved. So here the amplitude is A1, here the amplitude is A2. So the slope will be the product of both the amplitude, that is A1 into A2. In this case also it will be A1 into A2, and it is increasing up to T1 duration. So the maximum amplitude of this output pulse will be T1 into A1 into A2. So this was from the last lecture where we left. So in this lecture also, before going on, we will solve some examples. We'll take one example, like simple example we can take, and this will be very useful in communication system also, because and this will save lots of time. This will be directly not asked in the gate examination, but this question will be the part of some bigger question. Like some big question will be there of 2 marks. So in that you have to do the convolution where you can save your time by doing it using this shortcut. So let's suppose the input is here from minus t to t, or this time let's take some quantitative numbers, like it is minus 1 to 1, and the amplitude is 5, is convolved with another input that is from minus 2 to 2, and the amplitude is here 2. So first of all, what will be the duration of the output? So the duration of the output will be sum of the width of the both the input pulse. So the width of the pulse 1 is 1 minus minus 1, that is 2, and width of pulse 2 is 4. So the output width will be 6. Okay, and now what will be the this slope? That will be 5 into 2, that is equal to 10. Means the slope of the rising arm and also the decreasing arm. And it will start where it will start from. It will start from the sum of both the lower end of the input signal. So it will start from minus 3. So somewhere, let's suppose this is minus 1, this is minus 2, and this is minus 3. It will start from minus 3, and the slope is 10. Slope is a1 into a2, that is equal to 10. So in 1 unit it will increase 10 times. And what is the duration of the lesser width pulse? That is 2. So it will increase up to 2. So that will be 10. It will go up to here 20. This is 20. And after that it will become flat. And then again it will decrease by the slope of 10. Means at value 2 it will be around, it will be 10. Because the slope is minus 10 here, so it was 20. So after 1 unit it will decrease by 10 steps. So this is 10. So this is just the convolution. This will be very useful in communication system as well as in single system. This will be just a part of a bigger problem. Nowadays in GATE examination, simply they does not ask such kind of question, but sometimes they may ask in 1 marks question as well. So now we will see impulse response of a LTI system. The next topic is, so this is impulse response of LTI system. Let me check this video is getting recorded or not. Just a minute. Impulse response of LTI system. So let the output yn of a discrete time system is given as, when it is, let's suppose the input xn is given and output is yn. So the output yn can be written as xn convolution with hn, or you can write it as hn convolution with xn. As we've already studied last time, that convolution is commutative, have commutative property. So you can do either of the way, either xn convolution hn or hn convolution xn.
I could say just one doubt,
Yes.
which is better, Xen convolve Xn or Xn convolve Xn idea.
Yeah, like depends on the question. Whenever this comes up to integration and summation part. So in the question, if we see like what kind of HN and XN curves are there, accordingly we can take. But mostly we take XN convolution with HN, but both are equal and gives the same result. And just we can see which is easy to simplify, that we can use.
Okay.
There is nothing difference between both. So for discrete time, we can write it as Yn is equal to the summation HK. This convolution, Hn convolution Xn can be written as HK convolve with Xn minus K, and K will vary from minus infinite to infinite. So here this we can break it as, let's suppose h of minus infinite, just give it, just write the sum of the term. We will see why we are doing this. H of, it will come from k is equal to minus infinite to, let's suppose k is equal to minus 2, then it will be h of minus 2 into x of n plus 2 plus h of minus 1 into x of n plus 1 plus h naught into xn. Again, now when k is equal to 1, it will be h1 into x of n minus 1. So it will go up to k is equal to infinite. So now we will see like this impulse response for a memoryless system and system with memory. So for a system to be memoryless, yn must depend only on xn. And the only way this can be true is like hk is equal to 0 for k is not equal to 0. Because if yn depends only on xn, so what are the terms in this? We have written this, we have expanded this. In this expansion, what are the terms of xn here? This is h naught into xn, h0 into xn. So for a system to be memoryless, like all values where yn is depending on the different value of input like n plus 1 or n plus 2 or something like that, that will be like 0. That in that way we will say that system is memoryless, that it only depends on the current input like yn is equal to xn. It does not have any memory, it does not depends on any of the past input value or does not depend on the any future value. So let's suppose if we take like we are studying the impulse response. So impulse response, so hn will be here del n, or let's take some multiply it with some constant. Uh, so this will be like this. At 0 it will be k because we have multiplied with k. So this is the curve of k into del n. That is the impulse response. Now for all other value it will be 0. So what will be the value at h0? So h0 is equal to k into del 0. That is at del 0 will be 1. So it will be k into 1, that is equal to k. This is for memoryless system. The system does not have any memory. So it only depends on the current input value. So our y1, yn will become, that is h0, that is k into xn. So this was for discrete time system. For continuous time LTI system, we'll write for continuous time also, just will summarize it. Just simply our ht will be means h, and here the impulse function was depending on n. So that is on the discrete steps. N is equal to minus 1, 0, 1. Here it will be just a continuous. It will depends on the time. That is ht is equal to k into delta t. And ht is equal to 0 for whenever t is not equal to 0. At t is equal to 0, that will be some infinite value. So here output will be given as k into xt. In discrete time, it was simple k into xn. So now we will see for causal system depends on the present and past input value. Causality for the LTI system. So we have written yn is equal to hk into x of n minus k, that is summed over k is equal to minus infinite to infinite. So in this, we will see what are the terms which depends on the future input, terms depend on the present input and past input. We'll separate it out. So it will be hk x n minus k. So whenever like this n minus k is greater than n, then it will be the future output, future input. Means this output will depends on the future input. So this will, when it will become, when k is negative. This means minus and minus will be plus, so it will be n plus some quantity. So whenever k is equal to minus infinite to minus 1, this n minus k will be, like let's suppose k is equal to minus 3. So n minus k is equal to n plus 3. So this is just a future input. So this is just the explanation. So the output is here depending on future input. Now for k is equal to minus 1 to infinite also we have to see. So we have seen up to minus 1. Now when k is equal to 0, it will be h0 into xn. When you substitute k is equal to 0, this is the present input. This xn is present input. Now what values of k's are left? That is from 1 to infinite. So it will sum k is equal to 1 to infinite hk x n minus k. So these are the output depending on the past input. And output of the causal system depends only on the present and past value of the input. Output of the causal system depend only on present and past value of input. So we can write for causal system. For causal system, what are the terms left? Only these two terms we have to take. This will be 0 because it will not depends on the future input. So like whenever k is minus infinite to minus 1, this term will go 0. Then only we can say that this system is causal system. So for discrete time causal system, what will be the impulse response? For discrete time causal system, impulse response will be yn is equal to summation of k is equal to 0 to infinite. We will take from, this is k is equal to 0 here. It is here k is from 1 to infinite. So we are summing both the separate term together now. So it will be k is equal to 0 to infinite hk into x of n minus k. Okay, or equivalently we can do in another way also, like this is for hk convolution is xk xn. Now if we convolve xn convolution with hn, so equivalently we can write xk into hn minus k. Only thing is that this k will be from minus infinite to n. because this input is n, so the output is like yn. So here n for causal system, it depends on only the present and past input. So n will be either negative, like xk will be, this k will be either negative or up to n. So k is less than or equal to n. That's why we have done k is equal to minus infinite to n. This is for causal system. And similarly, we can write for continuous time also. For continuous time, we'll also solve some of the question after going through the theory, and we'll see some more like a stability condition as well after that. Then we'll solve few questions. So similarly, we can write here only the n and k will change into t and tau. Okay, so we have to just replace it, and summation will change into integration. So from 0 to infinite, here k will change into tau, so h tau, n will change into t, so x t minus tau d tau. Or equivalently, we can write minus infinite to t xt into h of t minus tau d tau. Okay, so this was for the continuous time causal system. Now we will see the stability of LTI system, and after that we'll solve few questions. If you face any difficulty, then you can ask. And also the student who will watch in YouTube, they can comment in the YouTube chat, YouTube comment box. I will reply there also. So we have already studied in the last lecture that a system is stable if every bounded input results in bounded output. That is also known as BIVO stability. So that is bounded input and bounded output. So let's suppose like Xn is input. Like in this, we have to assume that our input is bounded. Let's suppose Xn that is bounded in magnitude. So the magnitude of Xn will be less than m. Let's suppose some m is some finite value. Yeah, yeah. Hmm. X of t, because here the output is depending on the from like negative and the present value. So it will depend from minus infinity to t.
No, because that is not the form of evolution.
Oh, sorry, sorry. It will be x tau. It will be x tau. Sorry, because we are here d tau is there. No, actually, I mean, sorry, sorry. This will be tau because it is the integration is with respect to tau. So this x tau will be from minus infinite to the tau value is going up to t. This tau value is going up to t, which is from minus infinite to t. And say if you will keep t here, then it will not vary. It will be a single. It will come out. So yeah, you have pointed it correctly.
Okay, so even if you keep the integration limit minus infinity to plus infinity, doesn't matter. It becomes
Why? It will not become zero. Like if we will go more than t, like let's suppose if x of t plus one term come, then it is not a causal system. So we are discussing here only for causal system.
okay.
So that's why
You can say that is zero.
uh, we are assuming that for causal system only. So we are taking up to t only.
Okay.
So now stability of LTI system. So like we are discussing about bounded input and bounded output. So here let's suppose xn the input is bounded. So that is less than m, some finite value. And here what is our output? Yn is given as summation of hk into x of n minus k. K is, let's suppose, minus infinite to infinite here. This time we are not discussing about LTI system. This is not about causal system. That's why we have taken k is equal to minus infinite to infinite. So for output to be bounded, the magnitude of output should be also less than some finite value. And we know that the magnitude of this is always less than equal to the magnitude of if we do the magnitude of individual terms, k is equal to minus infinite to infinite magnitude of hk into magnitude of x n minus k. So this will be less than this, we know this, because the magnitude of sum of such number is not larger than the sum of the magnitude of the numbers. Because let's suppose if one of the term is negative, one of the term is positive, and here everything will come positive only, so this will be always greater than this term, because there will some positive term will cancel out with negative term in left hand side. In right hand side every time it will be positive, that's why it is less than that. So if we prove that this term is less than some constant, then we can easily prove that this is a stable, because if this is less than some constant, let's suppose m, then this will be also less than m, because this is less than this. If this is less than m, then this is also less than m. So therefore the output is also bounded. Not m, let's suppose some other constant we can take, because for input we have taken m, so here we can take some n or something k, anything. So let's see what we have to do now. So yn is equal to y is less than equal to summation of mod of hk into the mod of x of n minus k, and k is varying from minus infinite to infinite, and we know that this summation of like this xn is less than m, that is finite for all inputs. Okay, so we have to just prove that this term should be less than some, like the summation of this hk should be less than some constant value, like or it should be some finite value, then the system is absolutely summable. So for proving like this yn to be stable, we have to just prove summation of hk, that is k is equal to minus infinite to infinite, this is less than infinite. Matlab this is some finite value, or you can say that this is equal to some finite value. So this will result as a bounded output also when the input is bounded. So here the system will be stable, and for continuous time, what we have to prove? We have to just prove that this summation will change into integration and hk will change into s tau d tau. This is less than some this is equal to some finite value or less than infinite. So we can solve few questions on this. So let's solve one question. This is a GATE question from the GATE book. The impulse response Hn of a linear time invariant system is given by Hn is equal to u of n plus 3 plus u of n minus 2 minus 2u of n minus 7, where un is unit step function. So un is unit step function. So we have to just comment about it, stability, and whether the system is causal or non-causal. So we have to just find system is stable or not, and also causal or not.
So it is not causal because it depends on LPS3.
Yeah, it depends on n plus 3, so it is not causal. And also we'll see for stability, we know that the summation of hk should be some finite value. So we have to prove this is equal to some finite value. Then only we can say that this system is stable. So here the summation will be hk is u of k plus 3 plus summation of u of k minus 2 minus 2 into summation of u of k minus 7. So here our k is from minus infinite to infinite, but we know that unit step function is 0 when like uk is equal to 0 when k is less than 0. So this k plus 3 is less than 0. This means k plus 3 is less than 0. So k is less than minus 3. So for k is less than minus 3, this uk plus 3 will be 0. So that's why we have to take the integration from minus 3 to infinite. In this case, we have to take integration from 2 to infinite, because for k is less than 2, uk minus 2 will be 0. And in this case, we have to take from k is equal to 7 to infinite. So we can plot this curve like this is from k is equal to minus 3. This is from k is equal to 2. And this will be minus of 2 into u of k minus 7. So from k is equal to 7, it will just become minus 2 unit downwards. So it will be, so this is also going up to infinite. So here this is minus 2 and this is 1. So after you add all this, you will get the resultant signal will be like this. From k is equal to minus 3 to, sorry, this is the discrete time signal. So here it will be like just a pulse it will be. So now I will draw correctly. So at k is equal to minus 3, it will be 1 only. I will draw in the next page. So this you have to take as a discrete, like at every value it will be -2, it will be 1, like this. We can erase this one. So it will be like this. -2, -1, and at 0. So now for simplicity, let it be like this. Originally we will draw as a discrete signal, like the final summed value. So at k is equal to -3, it will be 1. At k is equal to -2, again it will be 1, because the only one signal is there. At k is equal to -1, it will be again 1. At k is equal to 0, it will be again 1. And it will be same up to k is equal to 1. Now when k is equal to 2, when k is equal to 2, it will be twice, because the two signals are added. So k is equal to 2, it will be twice. Up to 7, it will be 2. Now after 7, this 1 plus 1, 2 in the upper side, and this -2 will cancel out, and for all the value it will be 0. So the summation of hk, that will be our 5 into 1 plus 2, 3, 4. Sorry, at 7 also it will be 0. Up to 6 only it will be 1. Because at 7, this is 7. This -2 and this +2 will get cancelled. So it will be 5 into 2. So the answer will be 15. Okay. So this I have just drawn for calculation. This you can do directly only. No need to draw this. Even no need to draw this. We can directly calculate that this will be 15. Because after k is equal to 7, the other term will get cancelled. So we can do like this. From k is equal to -3 to 6, there will be summation of 1 plus k is equal to 2 to 6. This will be summation of 1, because after 7, this all terms will vanish. So we will get here 9 plus, not 9, k is equal to 0 will also come. So 9 plus 1 plus here 6 minus 2, that is 4. No, it will be 2, 3, 4, 5, 6. So it will be 5. So it will be total will be 15. Because for 2 also 1, 3 also 1, 4 also 1, 5 also 1, 6 also 1. It will be 15. We can directly calculate like this, or we can do the graphical method also. Now we will see for continuous time, we will also take one example. If you have any doubt, then you can ask in this question. Just wait for a minute. I will see video is recording. So for continuous time also, we'll take one example. The impulse response of a system Hn equal to An into Un. This means this Hn only depends for n is greater than equal to 0. For all other value, it is 0, because it is multiplied with unit step function. What is the condition for the system to be bounded input, bounded output stable. It is just asking for what value of A the system is stable. Like for what condition the system is stable. This is also based on discrete time only. We will take for continuous time also. The next example. So our Hn is given here as An into Un. So for bounded input, bounded output stability, we have to check the summation of Hn. N is from minus infinite to infinite is less than is equal to some finite value or less than infinite. So here we'll do minus infinite to infinite. A to the power n un, this will be equal to n is equal to 0 to infinite a to the power n. So now when this will be the bounded like this hn bounded by some constant k, only when a is mod a is less than 1. So we know that when mod a is less than 1, the summation will be 1 minus 1 by 1 minus a. So in that case, this will be some finite or less than infinite. So in this question it is asking what is the condition for the stability. So the condition is this only. The value of a should be from minus 1 to 1. That means mod a is less than 1. Means it will be something like 0.9 or minus 0.9. For everything, this summation will converge to a constant value. So now we will take, let's suppose in this question only, if ht is given as e to the power alpha t into ut plus e to the power beta t into u of minus t, and now it is asking like for what value this system is, for what value of alpha and beta, condition of alpha and beta, this is bounded input, bounded output stable. Here there is one twist is there, that it is u of minus t. Okay, so in that case what we have to do, like u of t is this curve, and what is our u of minus t, it is for the negative value of t only this function is defined. So now we have to prove summation of ht dt, that is from minus infinite to infinite, is less than this. So when we will plot this, for positive value of t, our e to the power alpha t should be converted.
Stability check is part of HRT, right?
What?
Uh, Checking stability.
It's just the integration. You can take anything like h of t, tau, k, anything.
No, so should be part of.
Mod of ht. Yeah, it will be mod of ht for discrete time also. Mod of hn we have taken. It will be mod of ht. So here it will be like for this system to be stable, this e to the power bt and e to the power alpha t should be converging. Like as we know that e to the power x curve is e to the power t, let's suppose here t curve is like this. At t is equal to 0, it is 1. This is our e to the power t. At t is equal to minus infinite, this is 0. At t is equal to infinite, it is infinite. But in this case, our curve should be converging. So for that, we know that e to the power minus t curve is like this. So our e to the power alpha t should be converging here, because when t is greater than 0, this e to the power alpha t term will come. When t is less than 0, then e to the power beta t term will come. So if both will converge, then only this system is stable. So this means here alpha t should be less than 0, and our t is positive. T is positive, so alpha should be negative. Okay, and now beta t should also be negative. Then only it will, sorry, beta t should be positive, because when t is equal to minus infinite, let's check. I don't know what should be. If let's suppose t is equal to minus infinite, then if beta is negative term, then it will be negative of something into minus infinite will be e to the power positive of infinite. So b should be positive here. Okay, so b should be greater than 0, because if we want here beta t should be less than 0, and t is already negative, so b should be greater than 0. Then only this beta t combined will be negative. So for stability, alpha should be greater than 0, and sorry, alpha should be less than 0, and beta should be greater than 0. So this kind of question is asked in GATE examination. This is previous year GATE question. Now we will see step response. We have seen question based on the impulse response. But we have not solved much question, like we have not solved question based on impulse response till now. We have solved only question based on the stability term. So I will check whether the some question based on the impulse response. First, let's see the step response of an LTI system. Then we'll combinedly solve both kind of question. So let's check step response of an LTI system. The same thing we will do what we have done here. Here instead of del t and del n, we will take ut and un, because we are dealing with unit step function, like a step response. So step response means it will have unit step, like ht, sorry, ht will be our ut or un. Hn will be un and ht will be ut. So the step response st, or you can say output yt, that is equal to, let's suppose this is our system, and if we give here xt as ut, so this will be the step response of a LTI system. Let's suppose this is LTI system. So the output, it will come as yt is equal to st. That is also a step response. And if we give ht is equal to, let's suppose del t, then our yt is equal to here ht. Okay, this we can remove. We can just combine it for both. We have already seen yt is equal to ht when our input was impulse. Now when the input is unit step, we will see what will be the yt. We can take some question directly on this. Before that, we can see some of the things like how to convert from like unit step to the step response to the impulse response. Like we have already seen that derivative of a step response is the impulse response. So derivative of uh, d of st by dt, what it will be the impulse response. That will be equal to derivative of ut with respect to t convolution with ht, and this will be derivative of ut is del t, that is convolution with ht. So we can see that the derivative of step response is the impulse response, and integration of the impulse response is the step response. Here ht is equal to derivative of step response. So ht is equal to integration of ht into dt. Okay, minus infinite to t. So just for converting from step response to impulse response, we have to derive it, means derivative, we have to do derivative of it, and for converting impulse response to step response, we have to just integrate it. So let's take an example based on this. If the response of LTI system to unit step input, here input is unit step, so this is the step response of the LTI system, is 1 by 2 minus 1 by 2 into e to the power minus 2t, then impulse response of the system is. So this is very simple question. Like we have already in the question it is given that the response of the LTI system when the unit step is given as the input, that is 1 by 2 minus half e to the power minus 2t. So our step response st is given as half minus 1 by 2 e to the power minus 2t. Now we have to find impulse response. The impulse response is equal to d by dt of st. This we have already written here, like this. ht is the impulse response, you can see here. So ht is equal to derivative of st with respect to time t. So we can simply derive it. So impulse response ht is equal to derivative of half is 0 minus half into minus 2 e to the power minus 2t. So it will be e to the power minus 2t. So simply if now if it is given that impulse response of a system is, let's suppose it is given as the impulse response. Now the step response of the same system we have to find. So in this, it is given impulse response, that is ht is equal to minus 4 e to the power minus t plus 6 e to the power minus 2t. Now we have to just find the step response. So ht is integration of ht dt from minus infinite to t. So here, and it is also given that for t is greater than equal to 0 in this question. So this integration can be written as 0 to t ht dt. So ht will be 0 to t, and we will write the terms of ht, that is minus 4 e to the power minus t dt plus 0 to t 6 into e to the power minus 2t dt. We will get minus 4 by minus 1, that is 4 e to the power minus t plus 6 by minus 2 into e to the power minus 2t minus 3. So this whole term we have to take. So 4, this is our integration, 4 e to the power minus t minus 3 e to the power minus 2t. This whole we have to take from 0 to t. So now the answer will be 4 e to the power minus t minus 3 e to the power minus 2t minus, when you put t, that will be 1. So this is the final answer. If you have any doubt in this, you can ask. This is a simple question. We have to integrate for finding uh, impulse response to step response, and we have to do derivative when we have to find the impulse response from the step response. Just a note point: impulse response is equal to derivative of step response, and step response is equal to derivative of impulse response. Sorry. Integral of step response. Thank you for correcting me out. Now we can see some question.
Just before going into questions, one common confusion I always find in convolution, computing convolution in discrete
Yes.
is, for example, when you are finding the term n minus a,
N minus.
n minus k, let's say, instead of minus n plus 2, something like that comes, how to switch it? I always confuse, shift and then flip or flip and shift, which one should be done first? Some example if you can take. For example, n minus 2,
Yeah, okay, I will take one example. Like,
something extra for minus and plus 200.
So let's suppose like example is we can take our action. Mm, we can take some simple example like for discrete term, like let's suppose this is our action. We'll take some short examples like for four values only. So
Something which is good for it, both sided.
both sided you want to take, then you
Yeah,
can take like
good is good to be symmetric, otherwise you get symmetric minus and plus and is there. So something asymmetric, you take both sides.
means what you told asymmetric.
Just to understand, take one example of asymmetric signal, both sides.
Okay, okay. So let's suppose we are taking like from here it is 0, it is 1, it is 2, for 2 it is 3, and for other values we are taking 0 here. So this is our, let's suppose, xn. Now let's suppose our hn is
No, no, yes, sir. This is only positive sequence, right? Only right hand sequence, no left hand.
positive sequence means.
No, here in this example, we have taken only right hand sequence. Yeah, all the things are only on the right hand inside of zero.
No, no, no. Oh, here I have taken, sorry, sorry, sorry. This we can do 0 minus 1, sorry, minus 2.
Just,
Sorry, sorry, by mistakenly I have written that. Now we can take hn as, let's suppose, this we can, let's suppose, take simple only. 1, 1. Let's suppose this is like this. So we can write it as yn is equal to xn convolution hn. And let's suppose we are writing xn as like this way. Hn we can simply write that del n plus del n minus 1 plus del n minus 2 del n minus 3. Okay, and we can write xn as this. We can write at minus 1 it is like this, so we can write it as 1 into del of n plus 1 plus this is 2 into del of n plus 3 into del of n minus 1 plus 4 into del of n minus 2. Okay, just a minute. So now we have to just write all the terms. or we can do in this method also, like we can write it as h minus k. This, let's suppose we are transferring into h of minus k.
Yes, sir. It means when doing the graphical form.
A graphical form only we will do now. Let's not do with this, because this will directly we can use the property of impulse. So we'll do graphically only. This method we can calculate using that convolution. So, um, so here the h of minus k will be this 0, 1, 2 and 3. बस 1 घंटा आधा घंटा और थोड़ी देर में आधा घंटा और so this is our h of minus k. So we have to just shift h n minus k, and then we have to write yn is equal to here. Our yn is equal to x of k into h of n minus k. So like for our xk is here from -1 to, but for discrete mostly we can solve using this method. This is very easy, using just the formula method. This also we can solve. 1, 2, 3, 4, and our h of n minus k we have to just shift all the times, like our h of n minus k is equal to 1 here. Sorry, sorry. Let's suppose we are taking here n is equal to h of minus k is there like this. If we are taking h of, like we are shifting to 1 unit ahead, so h of n minus k will be, like let's suppose n is equal to 1, so it will go 1 unit forward. So it will start from 210, sorry, it is -2, -1, -3, 0. So it will start from -2, it will be 1, -1.
So 1 unit left it shifts.
No, it will shift to right, because here it is h of minus k already we have done. No, no. If we are doing h of 1 minus k, like if you are just adding 1, then it will go to 1 unit right side. In this case, because here it is h of minus k. Don't get confused with this. Like let's suppose this is our uk. This is uk. Now when you are doing u of k minus k plus 1, then it is going towards left, 1 unit left. But but when it is u of minus k, and now you are doing u of minus k plus 1, then it will go 1 unit right way, rightward. Yeah. So that's why we have added plus 1. So it will start, instead of starting from -3, it will just shift one right side. So it will start from -2, -1. For 0, it will become, and one more term, it will be for 1. So now we will just see the common term and we can multiply it. So this will be for n is equal to 1. Uh, Only at -1 it is 1. So it will be 1 into 1 plus 2 into 1 plus 3 into 1. So it will be 6. So y of n for n is equal to 1, like y1 is equal to 6. Similarly, now we will calculate for all values where it is overlapping. So for y is equal to 2, we will calculate. Y is equal to 0 also we have to calculate. That is simply the multiplication of these two curves. So this will be at 0, 1 and 2. That will be 4 plus 3 plus 2. That is 9. Y0 is equal to 9. Y1 is equal to 6. Y2 is equal to, again you will shift 1 unit rightward. Then which term will be the common? This will start from minus 1. So minus 1, 2, 3, 4. All 4 will be common. 4 plus 3 plus 2 plus 1. That is 10. Am I calculating correct? Like y0 it is 0, 1, 2. So 4 plus 3 plus 7. For this it will be minus 1, 0 and 1. 3 plus 2 plus 1, 6. For next it will be minus 1, 0. Oh, sorry. Actually, for y0, this way I have to take. I have taken the above one. So it will be only the minus 1 and 0 terms. It will be 3. That's what I was thinking how y0 is so large. Y0 is 3, y1 is 6, and y2 is 10. Because when you are shifting 2 units, then you will get 0, 1, 2, 3, 4. So 4 plus 3 plus 2 plus 1 half. Y3 is equal to, when you are shifting 3 units, then it will 1, 2, 3. It will start from, this is our h of,
H of minus k plus k.
this is our x function. This is our h of minus 3. We have a minus 2. So this will be 1 minus k. We have to draw all those part individually. H of 2 minus k, it will start from minus 1, 0, 1 and 2.
Yeah. Yeah. So H of
H
3 will
of,
start with 0.
from 0. So it will be, so now which of the term is overlapping? That is 0, 1 and 2. So that will 4 plus 3 plus 2, that is 9. Now y of 4 will be, we'll shift again, that will be 1, 2, 3. So only these two terms, that will 7. Again y of 5 will be, it will start from 2 and 3. So it will be 4 into 1, that is 4. And y of 6, I think it won't, y of 4 will be h of 4 minus k. So this is 3 minus k. So 4 minus k will be 1, 2 and 3. So how many things are overlapping? At 1 it is overlapping, 2 it is overlapping, 4 plus 3, 7. Y of 5 only 1 is overlapping is 4. Y of 6 will be 0. So we will get the convolution as yn is equal to 3, 6, 10, 9, 7, 4. So in this way we can do, maybe some calculation mistake may happen here. You can shift it like this. Just you do h of minus k here, and after that whenever you add however unit plus n, so it will shift n unit rightwards.
Okay. Okay, so generally, which signal to maybe the signal which is simple, we'll use it for filtering, which is this is a combination. As I understand, one signal is fixed,
Yeah,
the
yeah.
signal is
Other
filtered.
signal we have to shift.
So we choose the signal which is whichever is excited, whichever is simple, that we choose for
That
that.
one we can choose. That will be
That
like
is easy for that.
easy to calculate. Okay, so now we can take some of the questions from here book. We will open it. So we'll take one question that is asked in GATE 2017. I think this question I have taken in the first lecture, but I have not solved that day because that time those topics were not covered, like convolution. So better I will write the question again instead of going to the first lecture slide. So the xt is given in this, and H1T2 system is in this form. The overall H is H1T plus H2T. Both are summed over, and here we get the YT. Okay, and in this question it is given that the impulse response of the systems are H1T, that is given as 2 into del of T plus 2 minus 3 into del of T plus 1, and H2T is given as del T minus 2. So if the input xt is given as, if xt is unit step, then energy of output signal yt r. So in this question, like H1T and H2T both are given, and the impulse response of the systems are H1T, it is given as 2 into this impulse of del T plus 2 minus 3 into del T plus 1, and H2T is equal to del T minus 2. So the overall impulse response, how much it will be? This is the individual impulse response. In this individual impulse response from the second system. Both are here summed. So this is H1T plus H2T. So the overall response is summation of H1T plus H2T is equal to, let's suppose, HT, that is equal to H1T plus H2T in this case. So our HT is equal to 2 into del T plus 2 minus 3 into del T plus 1 plus del T minus 2. So now the input given as xt is unit step. Xt is our unit step. So output yt is equal to xt convolution ht. Okay. So yt, our xt is here ut. So ut convolution ht. Ht is 2 into del t plus 2 minus 3 into del t plus 1 plus del t minus 2. So we know that whenever like ut is convolved with t plus n, then we get u of t plus n only. Okay. So in this case, yt is equal to ut convolution 2 of del t plus 2. That will be here u of t plus 2, and again here it is t plus 1. So it will become minus of u of t plus 1, and again it will become del of t minus 2 convolution of ut. So again this time is minus 2, so n is minus 2, it will become u of uh, t minus 2. So u of t plus 2 from here, this is minus 3 I left, sorry, minus 3 u of t plus 1 u of t minus 2. So now we can draw this curve. Hmm. Sorry. I missed the constant in all this. Sorry. So it is 2 of ut plus 2 minus 3 of ut plus 1, and in this there is no constant, so u of t minus 2. So we can draw this curve. So we will get 2 of ut plus 2 is, like, it will start from 2 and the amplitude will be 2 here. This is the first curve. second curve is 3 of ut plus 1, or let's do here only, or we can directly sum it instead of
No, 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 sir. U of t plus 2 should be in the left side, right?
sorry, in the left side. U of t minus 2 is from here. So we can directly sum, like from t is equal to, this suppose is minus 2. Beyond minus 2, there is no signal. So it will be 0. From t minus 2 to t minus 1. Sorry. T is equal to not t minus 2. T is equal to minus 2 to t is equal to minus 1. There is only this signal is there. So the amplitude is here 2. Now, from t plus t is equal to minus 1 to t is equal to 2, this will dominate, this will do minus 3 to 2. So it will become minus 1 here. It will become minus 1, and it will be up to t is equal to 2. So this is minus 1, this is plus 2, and at t is equal to 2, what will happen? This is 2 plus 1. 3 minus 3 will become 0. So this is 2, this is minus 1, this is 2. So this is our output signal yt. I have directly summed all these three signal. So we got this as a yt. Now in this question it is asking energy of yt. So energy, we know that it is just the summation of square of the signal from minus infinite to infinite. So when we do a square of this, we will get from minus 2 to minus 1, it will become 2 square, that is 4. This is 4. And from minus 1 to 2, it will become the square of minus 1, that is 1. So from here, let's erase this. This is minus 2, this is minus 1, and it will go up to 2. So now the area of this plot is the energy. So the area will be from, this will be 3 into, this is 1, this is 4. So 3 into 1 is, and this will be 1 into 4. So that is equal to 7 joule. So this is the answer for this question. This was asked in GATE 2017. 17. So this was asked in 2 marks. So nowadays they are just asking from cascade or summation of multiple impulse response, and they are asking little tougher question. I think today we can stop here only. And in the next lecture we will what you have suggested, we can go in that way, that we will take the lecture from the week 5, as week 3 deadline is already over. And
Yes. So the big figure exam, based on which
yeah. Little I can take 1 or 2 example from week 4, and then we'll jump on to week 5, and from after that we will have that same maintain. Okay, thank you so much for attending. And if any students watching the YouTube lecture have any doubt, they can comment in the comment box. There may be some mistakes in the calculation and slides, so that we can correct it out. And if any conceptual doubt, that also they can reply in the YouTube comment box. I will reply there. Thank you so much. We can close the lecture here. Thank you, everyone.
Thank you.